So today I'm going to be installing rib nuts in order to mount the roll axis panel, or the roll axis plate, and the idler plate. And to do that, I need to use this fancy rib nut tool. I'll show this to you here. And you'll see it get used here in a few minutes. These are really kind of neat and they work well for the kind of stuff I'm doing here. So let's get on that. Okay, let's get these holes drilled. And 4. Get this mess cleaned up. And now I'm going to grab the rivet nut tool. We'll get these installed. The way this works is I go ahead and thread the rib nut onto the tool like so, and then it kind of works like a pop rivet. I go ahead and I put the rib nut here into the place where I'm going to mount it, and then I just squeeze these things together and it pulls it. Thread them just a little bit more, and we'll pull it again until we can't anymore. And then we take this out by unthreading it here. It's kind of tight, it doesn't want to unthread. Go. We have one good installed rivet, or rib nut. Then I just do that again for all the other ones. And this is kind of annoying to do with you guys along for the ride because of how I've got everything moved around for the camera. But it's worth it. If I hold it closed just a little bit, it's easier to unthread these things. Okay, that's 4. I've got 4 more to do, but I'll save you having to watch that. I wanted to add a little bit here in the beginning of the video that gives you an idea as to what's going on, because the work this video encompasses is about 3 weeks-ish of a couple hour a day or work in the evenings, and then some Saturdays and Sundays. So it's kind of weird and scattered, and I had to come back and redo things because I fell short of parts and things like that. But essentially what is going on is the original design that I had done for the control loader wasn't going to work out. I had shown that video to my friend Wayne, who is an actual engineer, and he offered some suggestions. And when an engineer of his caliber offers you suggestions, you treat that man like he's E.F. Hutton, and you pay really close attention to what he's telling you. And as a result of that, he offered up an interesting alternative to the design that I had done, and I liked it and I went with it. So the footage that you're going to see after this is all about assembling that new system. The video that's coming after this will show me installing and setting up the actual production control loader parts. Everything that you'll see in the video is basically test parts. It's scrap plywood, things like that. It all got remade in Baltic birch, painted, looks great. And with that being said, I'll let you get back to the rest of the video. Now we're going to drill the new holes for the servo mount. And this is the pitch axis, I think, and it looks good. So we start the job. There's a slight delay because it allows the motor to spin up, lets the pump start, and then we're going to start drilling some holes. 4 of them to be exact. And that's all there is to it. 4 very precisely located holes. Woo! So you've seen me drill holes in the past, so I skipped it. What I'm doing right now is prepping these panels to take the threaded inserts that I'm going to use. And I'm making a hell of a mess here. But these are going to get sanded and properly painted after, I'm sure, everything is going together. So what I do is I use I think it's a 6mm Allen wrench, and this is what the inserts I use look like. They've got heavy threads on them, and they use an Allen key or a hex wrench to install. And that way I can do it this way and not have bolts or nuts and things like that I'm dealing with. I just go ahead and thread these things in here and try to keep it straight, which it is giving me grief about, of course. Probably can't see me working real well, but it's just the way it is, I suppose. There we go. And it's mostly kind of straight-ish. Yeah. No, not really. Well, I can remake these if I need to. They are just plywood. Need something to drink. Okay. Let's go on to the next one. We'll get it all cleaned up later. Okay, where was I? Doing that, okay. One more. Okay. This is the front end. Looks pretty good. Just set this down a little bit. Kind of a mess. I do believe I fucked up. think I did. We'll find out. I did not. I thought I had made a mistake and installed 6mm threaded inserts when I should have installed 5. And no, I'm fine. And these inserts are a hot mess. Oh yeah. This is no joy. Yeah, my problem is that because I was not being very diligent installing these things square, 6mm has very little travel in here in the slots, and because of that, it's resulting in an installed bracket that is twisted this way instead of square. So how do I fix this? Okay, so in order to straighten out my little mistake here, I went ahead and put just 2 of the screws here and back and took a measurement off my CAD drawing to make sure that each side of this was 132 millimeters from this face. And I have that. And this will work well enough for the testing that I need to do. Now, the other mistake that I made is I forgot that these motors are threaded already for the mounts. And I also forgot that they are M6, not M5. And I'll show you why that's an issue here. I'll go ahead and put that in there. And these are the new plates that I'm using. And you'll see how these go together here in a second. But the plate goes on here like so, okay? And then I have a spacer that spaces this off. And then another plate goes here. And then I have a pair of idlers that fit in these upper corners here. My problem is that I do not have enough, or I don't have these in the right diameter. These are great for 5mm, they suck for 6. So I'm going to have to remake these in 6mm really quick. So I will go do that now. So I went ahead and got new spacers printed out, and we'll start putting things together. I went ahead and got the inserts done. This is the roll axis mounting plate, and I also printed up some alignment jigs. And essentially what you do is I will use this to correctly put the distance of the front face of the pulley here from the edge. And that way, when it's all said and done and it's installed in the jet, the belt is going to correctly line up with the control arms. So let's start doing that. This is the roll motor. So I think I will just get this lined up generally first. And I still have the same issue with the alignment on the stupid inserts, but that's a me problem, not an anybody else problem. So what I was checking was the distance from the face of the servo bracket to this leading edge here, and I wanted to make sure that I get it square for the initial setup, and then of course I'll have to adjust it back and forth once I know precisely where the motor's going to sit according to each of the jigs that I made. Looking at 70 millimeters here. So loosen it just a little bit. That is close enough. This cracked me up. When you buy this pulley off of Amazon, you actually have to buy the grub screws separately, and that just blew my mind. I mean, I know it's cheap, but having to supply your own grub screws is just a whole new level of cheap, I guess. I've got 2 set screws here, 2 grub screws, and then the shaft has got 2 flats on it. So that's what I want to get these lined up on. Let's see, I've got that. And it moves around a little bit, and that's okay. So I will take my alignment jig, my roll axis, and I think I will clamp that in place. Get that set just like so. Get that put right in place there. Make sure it's square. It looks like it's 67 millimeters. Just a little bit. Okay, so 67 millimeters is the point that I want to shoot for. Okay, let's go to 67. That's 67, and that is 67. So we'll just tighten these down. I hope they don't move. And we're good and we're good. Okay. Okay, so now we've got the roll servo, and then we need this first doubler plate here, or the first support plate, and I need to get 45 millimeter M6s, I think. Hang on. Whoops. So I've got 45 millimeter M6s. So we've got to build us a stack here. Oh no, I don't need them that long. Why am I thinking M40 or 45 millimeter? I don't need them nearly that long. Let us figure out how long I need them. I'll be back. So here's my problem. I don't have the right fasteners, which is just irritating the hell out of me. And this is back to that problem I talked about previously with having or thinking that these were 5 millimeter and not 6. And I've got various lengths in 5, but not in 6. So now I have to go buy some more material. Fiddlesticks! Okay, I will be back to this when I have the right fasteners. So, woohoo! Back in a bit for you, few days for me. I have now got the fasteners that I need. So let us get this thing put together. We're doing pitch axis first, which is that beastie there. So let's start getting this put together. Actually, what I'm going to do is build a stack where I go. that the face I want out? No, that's not the face I want out. I want the textured face out. And these are just test parts. If it works out the way I hope, I will recreate these in either a much more dense plastic or infill and use PET or ABS as opposed to the PLA. Or I'll make them out of 1/4-inch aircraft ply, or I'll make them out of aluminum. I haven't decided yet. Okay, there's those two together. Like so. Start getting these hooked in. Nope. That's that one. Standoff is good. Now I need to put my belt idlers in. Okay. Let's try better than that, shall we? And my belt idler bolts need to be how long? Wow, looks like 30 is the winner again. These bearings on them. I need to get some lock nuts though, so grab a couple of those. Should probably washers or no washers? Nah, that looks fine. We won't do washers. We'll just do nuts. Okay. Let's see. 8mm? No. 10. There we go. There we go. And now I can tighten the rest of these down. They're not as smooth as they could be. I can fix that by opening up the spacers, maybe 1/2 millimeter. So that's what the whole assembly looks like. So there's one. That's for the pitch axis. Let me grab the roll axis. And we do the same thing. Oh, I appear to be short of one here for a set of bearings. So we'll get one set here. And then I will go chase down some bearings for this one. So back in a flash. Got the RZ44 bearings in I needed. So I got the roll axis assembled. I needed to pull out the bearing, or not the bearing, I needed to pull out the pulley a bit to get it to properly align. It was originally located in the older model that I had designed, and because of this, it needed to come forward just a little bit. And I think we're just about ready to get that thing installed. As you can see, a little change that I didn't expect. So it turns out that this height is great for the pitch axis, but not for roll. And the reason that is because the control arm for the roll axis is not as high in the position it's in as in for pitch. So I had to shorten this so it was no higher than 140 millimeters. And so that's what I had to do. I've also got the left-right adjustment, so the belts should center properly now, which was kind of an issue earlier. So the way that the control system is set up is that we've got a belt that loops around to connect to one side of the flight control, okay? And this is an example, or this is what I'm using for the pitch axis, okay? And the belt will loop through this and go this way, and then a loop through this and it goes this way. The problem is that on the aft end, it needs a way to turn around and come back to the motor. And my original plan was to use something that looked like this, which was kind of ridiculously tall and would have a couple of pulleys that would redirect the belts back towards the motors. And yeah, that's not going to work. I mean, it would work, but it sucks and it's not going to get the job done right. So, as part of the things that Wayne and I discussed was doing something that could be adjustable. So, in order to meet that goal, I've come up with this setup here where I've got the plate and I've got it moved around so you can see it more easily. But these are just, it's a 40 millimeter wide bit of 12 millimeter Baltic birch. And how long is that? It's, what, 155 millimeters long. And there'll be a hinge, one of these little hinges here underneath it, each one, okay? And it'll, you know, I don't know if I'll mount it here, it'll be mounted, you know, somewhere in here, okay? And then I'll have a wide pulley attached to the top here, okay? And then, so when it's in its working position, it'll be sit up like this, okay? And the belt will come in through the top and then go out the bottom, or come out the bottom, or, you know, come in the bottom, go out the top. Depends on what it needs to happen. Let's drop the damn thing on the floor. And then what I'm going to do is have, in order to keep adjustment or keep a constant force on this, this will be held in place or augmented in place by one of these little eye bolts here, and that'll go in, you know, something like so, except the eye bolt will be on the back face of this. And then I'll have a turnbuckle attached to that and a spring attached to the turnbuckle, okay? And the spring will attach to a rib on the inside of the fuselage, okay? And when I shorten the turnbuckle, it'll pull on the spring and tighten the belt on that side. So that's the goal of that whole thing. And with that, I think I'm going to go ahead and get this assembled. And I'm debating, where am I going to put that hinge? And all that was my internal dialogue as to where I'm going to put the hinge. And this is how the panel is going to be oriented, installed in the cockpit. And I'm thinking, because I'd originally printed some of these little spacers to get the hinge barrel here lifted off the surface so I could put this anywhere in here. But, you know, thinking about it and seeing it, I think I am just going to put the hinge right here in the center. And these two lines here are the belt path center lines. So we'll have it something like this with the hinge closed, and yeah, that'll work. That will get the job done. Okay, so oh, for God's sakes. Don't they know I'm filming here? Okay, I'm marking the centers where this center hole in there is going to go. But in order to do that, and not have to spend a whole pile of time measuring things, I'm going to cheat a little bit. So basically what I'm doing is, this is 2 5/8, I think. I think that's what I measured out. Yeah, 2 5/8. And no, I mean, and that's what, like 68 millimeters. Anyway, what I'm going to do is measure or draw diagonal lines, I should say, that will give me the center of that space. So I go from this corner here to where that line is. Make a line there. Cross is going to be the center hole. Okay, I am going to run off and pilot drill all of this stuff, and I will be back. Okay, got my holes, pilot holes drilled. I discovered that I did need to use these because I can't put the hinge on the edge like I thought. And I had forgotten that I have a mounting bolt right here where one of the hinges is. So I just moved them up a little bit, and that should straighten it out as far as getting the hinges set up. So let's take these apart and we'll go from there.
create. As you can see, these are pretty beefy. These pulleys that I made, I printed them with 10 walls, 30% infill, and 5 top and 5 bottom layers. And these things are heavy. This is probably, without the R4ZZ bearings in them, they're probably 2.5 ounces a piece. Regular. Yeah, that'll work fine. Well, until it doesn't work fine. I was afraid of that. See? It's sticking out just a little bit. So I gotta go fix that. I will be back. Okay, got that all handled. So we'll go ahead and start getting these assembled. So that goes like that. How was I gonna do that? Let's those. Where's one of those? Yeah, almost. Oh, got it right the first time. Turn just a little bit. This all needs to be squared up. Just a little bit offset because the bolt I'm using is not nearly as large as the hole. Get that straightened up. And then we put that in there. There we go. So there's one completed turnaround. Okay, so there we go. Got some tensioning arms here now. So next I need to drill holes for these that go into a rib in the fuselage. So I will go take care of that right now. Doing a bench test here. Got the pitch axis and the roll axis all connected up to that tiny little controller and the 24-volt power supply for the motors. So what I'm going to go ahead and do here is move the camera to a static position and then start plugging things in, and we'll see how it goes. I've added blue tape to the pulleys of the motors to make it easier to see if and when they move. So my first task here is to plug in the controller, and we'll see how that goes. I'm going to set up a screen recording so you can get a better idea of what I'm doing here. So what I'm going to do is I'm going to start adjusting the roll motor, so it is at 0. And you can see on the screen here, I'm adjusting the x-axis. Now I'm going to tweak that until it is close to 0. Boy, it's real touchy. Okay. So I'm going to have to mark that as my 0 point. And we'll do the same thing for the y-axis. Going the right direction? Yes, we are. Whoops, went too far. And I will call that good. Okay, I need to power this thing down so the motors won't move, and then mark my center point. Everything is fully rigged and tensioned up. It's all aligned and connected and looking fantastic. The next video portion of this you see will be with actual production mounts here. I'm going to replace those with 18mm Baltic birch that don't have so many test holes in them. And I'll get the electronics in that bay there, and then we'll get to doing some testing. I'm really excited and looking forward to that. Okay, we're going to have us a look under the cockpit floor here, because I need to identify that connector right there. That is a 66-pin cannon plug that connects the flight stick and the stick force sensor box to the rest of the avionics in the aircraft. And now I need to make a wiring harness that will mate to that and then connect to the shift register board for the VPForce controller. So I need to get that done before I can install the control loading system. So, fun times. So we're back real quick. I wanted to show you that I had found the connector that I needed. And that is the correct connector that mates to that plug. I kept all of the original wiring that was in the cockpit, and I did that because I needed to be able to have cannon plugs and not have to buy them. I do have a part number for that connector, and I can buy it, but it's $121 for just one. And the pins, I think, are $2 or $3 each. And for this particular situation, I need 27 of them. So yeah. Anyway, I'm going to go ahead and unplug this thing. And I wanted to take a look because I noticed in the previous bit of video that there was a bent pin. Come on, you bastard, focus for me. And I will take a look at that to see if there's actually a bent pin. If there is, then I get to take that harness out and replace that pin, which just irritates the shit out of me, but it is what it is. In fact, I'll go ahead and I'll show you what the business end of that cable looks like. This is the top side of that connector, and that's the original SFS cable that was in the cockpit when I got it, but it had spent a number of years outside, and all of the sockets in that connector were corroded. So I basically took it apart, repinned it, and then put it back together. You can see the wax lacing tape I used in there, and I think I even was able to reuse the nylon loom there. But this comes up and it plugs into the SFS box. And yeah, this is a little level I used to find my 0 point for the flight controls. So that's all there is for that. Thanks for watching, folks.